Hey everybody, this is Alex Merced, and welcome to this subsurface presentation of best practices for ingestion data or for ingestion of data into Dremio with Dremio Catalog. Now, my name is Alex Merced. I'm the head of dev role here at Dremio. So I've been with Dremio now for 4 years, talking about data lakehouses, Apache Iceberg, Apache Arrow. Gotten to speak at events like Data Day Texas and Data Council. Basically, the host of several podcasts. As you can tell, I like to talk, but also I've gotten the honor of getting to contribute to writing things like Apache Iceberg, the definitive guide, Apache Polaris, the definitive guide, which if you would like to download for free, if you haven't already, scan this QR code. And you can also from there find the link so you can download Apache Iceberg Digest Volume 1, which was a joint effort with Dremio, MinIO, PuppyGraph, Fivetran, Confluent. Go check that out. Now, what I want to talk about today is data ingestion, because at the end of the day, with Dremio, you have a built-in lakehouse catalog. Now, if you have your own Iceberg catalog, that can get connected to Dremio as well. But if you don't have an Iceberg catalog and need an Iceberg catalog, we got one for you with lots of great benefits, where you can land your data in Apache Iceberg, and we can take care of the optimization pieces. But you still got to figure out how to get the data in there. And we're going to talk about a lot of the different options you have today. And the reason why this is important, okay, when we talk about ingestion, we're talking about moving data from non-analytical systems into your analytical platform, okay? Now, things used to be really complicated back in the day because everyone had their own analytical platforms across different departments and people were sharing data across different departments. So it wasn't just moving data from your transactional systems to your data platform, but moving it from other people's data platforms to your data platform. But luckily with the lakehouse, we're now moving towards a world where basically we have one shared platform throughout the enterprise that allows every department to kind of use their preferred tools but work from one platform. And essentially in the process, when you're doing this, you're doing either one of two things. You're doing ETL or ELT. Okay, what does that mean? ETL just means in the process of moving the data, you're transforming it. So basically, what is left in the destination is the already changed data. Versus ELT, where you're moving the data first, the data lands in the destination, and then you'll generally transform it from there, which is becoming more and more popular as people do things like you hear like bronze, silver, gold, where basically people land the data as is. Then they'll create another version. Check out my transformations presentation here at Subsurface, where I'll go more in detail about that. Okay, but the end result, the idea is you want to have nice quality Iceberg tables for you to build your analytics on top of. Again, with Dremio, this makes it a lot easy because you can land your raw data. You can then build your different layers on top of that, 3 SQL views, and with Dremio, and since with Dremio's acceleration features, it can automatically determine sort of what bits and pieces should be materialized, when they should be materialized, when they just need to stop being materialized to get maximum performance, but at the same time, minimizing your compute and minimizing your storage costs to make that data platform performant. So ingestion best practices on a high level, things you want to do. One, you want to load data in efficient batches, ideally. Okay, so again, not every time you're going to be able to do data through batching, meaning, instead of just loading it as data comes in, you wait for a little bit and you do sort of chunks of data at a time, like maybe every hour, every day, every week, every month, depending on sort of the data you're working with and how often you have new data. But you basically want to kind of think through sort of when are you getting sort of critical amounts of data to then load into the Iceberg table. Now, the reason being for this, like the more efficient your batch process is, the less op maintenance is required at the table. Because then, hey, if I already have sort of all the data for a particular partition and I'm loading it at one time, then that basically the data is going to get written pretty much in the most optimal way up front, which means optimization on the other end is really going to be non-existent. Okay, and that's going to allow better performance up in the long run, and also reduce the cost of doing maintenance of rewriting the data because you did it in small pieces. Like maybe let's say I'm partitioning the data by day, but I'm loading the data by hour. Okay, well, by the end of the day, I could probably, some hours are going to have more data than others, and if I had just loaded all the data at the end of the day, I would have had upfront the optimal sort of written physical version of the data versus me writing it every hour. In that case, I probably should partition the data by hour. But again, that depends on your query patterns. and again, and the reason for that is you want to avoid the small file problem. So you also do want to make sure you do compaction, meaning you do those maintenance operations on a regular basis. Again, Dremio, if you're landing the data in Dremio's catalog, Dremio can kind of take a lot of this right off your back and just handle it automatically for you behind the scenes. So you don't have to even think about it. You just put those tables in Dremio's catalog and we'll keep them in nice and good shape. Okay. By automatically compacting them. Okay, automated ingestion with pipelines and monitoring. At the end of the day, you want to know what happens because things do go wrong, can and will go wrong. So you want to make sure that you have systems in place that give you information. Okay, so if you're using some sort of like orchestration framework, like let's say an Airflow, you want to make sure that there's steps that actually, populate some log data somewhere, so that way you know sort of what data was loaded, when the job's complete, any information you can. That way, when something goes wrong, you're able to figure out what you need to replicate, and your backfilling job becomes a lot less difficult. Okay. Use schema evolution thoughtfully. Don't just add columns because you can. Okay, so what happens a lot of times is people change how the data looks upstream, and basically, we're like, well, there's additional fields, so downstream we're just going to accept them. This is where sort of getting everybody on the same page and just sort of, this is less technological but more cultural, of having the conversations between all the different people who touch the data at different places and kind of getting on the same page of what the data should look like and what, so that way, you don't wake up one day and a column is missing and now you have nulls, or an additional column is happening and that's causing errors, or a column got renamed so the data is there but you're not capturing it because you weren't capturing that particular column. Okay, well, you can just update the schema. So for example, if you're using something like a Kafka Connect connector, it does have a schema evolution sort of knob you can turn on, where if it sees a new name for a new column, it'll add the column for you and then let you work it out later on downstream. But you're going to end up having sort of the least friction if you just have regular communication across upstream and downstream to make sure that everyone's kind of on the same page of what the data should look like. This kind of pattern is oftentimes referred to as data contracts. Oftentimes they're talking more about like, hey, trying to put some sort of technological mechanism in place to prevent this, but also, just picking up the phone or sending an email and having these conversations can be just as good at kind of help prevent these sort of mismatches of schemas and things like that. And to the extent you can, if you can do append-based pipelines. Now, of course, there are times where historical data changes, so you're going to have to do things like upserts. But if you're not in a situation like that, where you can just add data that comes in, and there's never a need to go back and update the old data, you're going to just get more optimal writes up front, less maintenance overall. So when possible, if you can structure a job, and again, there's lots of ways of looking at this. So for example, if I have data that comes in every day, okay, and generally if anything goes wrong and anything needs to be updated, it happens within, like, let's say 48 hours. Okay, so then maybe what you do is you might still do daily ingestion, but you might stagger it out 48 hours. Okay, so that way, basically, when you do the append, you're only appending the data that is in its sort of finalized form. And again, that depends on sort of like the latency you need in your data and sort of what the end use case is. But again, the only way you're going to know if that's an option is if you ask the questions of your end downstream users, that what are their needs, what are their latency needs, so that way you know what flexibility you have in designing these systems. Okay, a lot of this, the technology can only be so good, but it doesn't prevent the need to have these kind of conversations. Even AI doesn't prevent having these kind of conversations, because if AI doesn't know your requirements, it can't design things to your requirements. So you need to have these conversations. You need to talk about, hey, why are people designing the things that are coming from upstream the way they're designing them, and what do the people downstream, how do they intend on using the data, so you can design thoughtfully on both ends. But on a technological side, Dremio is here to be, well, your friend and partner in this process. And Dremio Catalog, which is powered by the open source project Apache Polaris, which was something that Dremio collaboratively created with Snowflake. So essentially, both companies saw a need for there to be sort of an open source standard for lakehouse catalogs, something to kind of replace the old standard of Hive and offer sort of that open standard among sort of this burgeoning market for Iceberg-based catalogs. Okay, and essentially that collaboration became Apache Polaris, which became now the foundation of Dremio's open catalog and Snowflake's open catalog. But so when you have a Dremio account, especially on Dremio Cloud, you're going to have a built-in open catalog, a built-in Polaris-based Dremio catalog. And that's going to give you the full power of open source. And one of the key things, the reasons why you want a catalog is for governance, okay? So a catalog in your lakehouse provides access control. So that way, when you say, hey, this user doesn't have access to this table, they can't connect to another engine and get access to the table. And because Polaris supports something called credential vending, they can't try to sneak around that by going directly to the storage, okay? The only way they're going to, basically, they don't get storage credentials. Instead, they only get credentials to the catalog, and the catalog is only ever going to give them access to the tables you give them access to, no matter what tool they use. So you not only have portable governance, but you have extra level of governance where you don't have to give them direct access to storage, but they'll still be able to access the data on your lakehouse storage because of that credential vending feature. And that's probably going to be one of the number one reasons why you're going to want a catalog that works the way that Polaris works. Okay. Now, Polaris has a lot of other really cool features that are coming down the road, the ability to kind of support other types of formats other than Iceberg, and the ability to federate other catalogs and things like that. But these are all things sort of like looking down the pipeline. But the core thing that Polaris is going to bring you is that sort of solid production grade catalog that's going to bring you that portable governance. And then when you take the Dremio wrapper on top of it, it's going to be much easier to use and also have those auto optimization features so that way Dremio can optimize your tables. But when it comes to getting data into that catalog, and again, it doesn't mean you're putting the data in the catalog. It just means the catalog is tracking the data and the data is existing in your storage. So that could be like an S3 or Azure, wherever your data lake storage is. You could get that data in there using Dremio. Dremio has plenty of ways to write data to Iceberg. You could use external engines like an Apache Spark, Apache Flink, or custom tooling, okay, to write data to Iceberg. Okay, there's a huge ecosystem of tools that write to Iceberg, and because you have an open catalog, okay, with Dremio that's based on the open Apache Polaris, the open source project, the community run project, Apache Polaris, you'll be able to connect that catalog to whatever tool you want to use that tool to write. You're not locked into using Dremio. We hope you do. We try to create really great tools for you, but you have options. So approach one, again, you can ingest with Dremio. And Dremio is going to generally have 5 paths for getting data into an Iceberg table. There's going to be CTAS, create table as, where you can take the results of another query. So you could query a Postgres table. Let's say you have Postgres connected to Dremio. You could query that table and say, hey, create a new table in my catalog that's the result of this table. And the cool thing about this is I keep saying your catalog. Dremio, again, has that built-in catalog, but you can connect external Iceberg catalogs, and Dremio can write to those external catalogs. So whatever Iceberg catalog you have, these features will work, okay? Basically, your ability to write to Iceberg is not limited to Dremio catalog, but to any catalog that you have, because they all share the same REST catalog specification, the way that catalogs talk to tools. So Dremio can talk to any catalog and write Iceberg tables to it, but you get the added benefit when you use Dremio Catalog is that we'll handle the optimization for you. But again, you also have the ability to use insert statements, copy into, which we'll talk about a little bit, and we'll even demo it. Create pipe is just lets you automate copy into, and then file upload for really small ad hoc jobs. You can just ad hoc upload a CSV file, a Parquet file, a JSON file, and turn that right into a Iceberg table. But again, with the CTAS statement, what you can do is you just take some query, and again, that can be on any source, any query that Dremio can run. So you could be querying a Postgres table or joining a Postgres table within a Snowflake table and wanting to take the results and turn it into an Iceberg table. You can do that, okay? You're just creating a table out of the results of another query. Now, this is good for when you're first creating the table. So you have a data set that's in one system and you want to just move it to Iceberg. CTAS is going to be a really easy way to just move from point A to point B. But going forward, you're going to may want to insert more data. So maybe like the other table is still getting the data and you want to go insert the new records from that table to the table you created with the CTAS statement. Then you can use insert into, okay? And I can use sort of logic that says, hey, don't insert all the records from the original table because I already have most of those records. You can use some sort of logic that, only gets the records with an ID above or from a created at timestamp to make sure that you're only appending sort of the incremental new records. And again, this just depends on how you're modeling your data, on how you would approach this. But the idea is with insert, select, and CTAS, you can just take the query of another Dremio source, which can be things again like Snowflake, like Postgres, like Mongo, and move that directly right over to an Iceberg table. So it really makes it anything that can connect to Dremio now becomes something that's easy to move over to Iceberg. Copy into is more for like you have files on your data lake. So you have a folder of JSON files, a folder of Parquet files, a folder of CSV files. And typically what you'd have to do is, especially for like CSV files, oftentimes the data in the CSV file has no schema. So you have to kind of treat it like text. So then if I were to just do a CTAS statement, I'd end up with this table that has all varchar columns or text columns. And then I'd have to then go back and alter each column type, using the Dremio's typecasting functions and create a view that converts these types. But that just means that now that type conversion has to happen every time that these views get queried versus having the data natively in that type. With copy into, what you do is you create a table first. So first you create a table that has a schema you want. And then what you do is you tell Dremio, look in this folder or look at this file on my data lake. There is Parquet files in there. There is PDF files in there. There is JSON files in there. And you say, read those files, take the data from each column and make sure that it matches the data type of the destination table. Okay, so whatever, in this case, you don't have to worry about, schema-less files because we know what the schema should be because the destination Iceberg table has a schema defined that we can then leverage. So it makes it really easy to just say, hey, take the data from these files, put it in that Iceberg table. But you may have a situation where you're getting, like, let's say you have a file, you're getting a bunch of CSV files that you're exporting from, let's say, like a tool like a QuickBooks, and you do this like once a month. So every month you're loading new CSV files that have all the additional records of invoices, bills, things like that. Well, this is where you would use something like a create pipe, where you say, hey, you point it to the data lake, the folder where it has those Parquet files, and it will run on a regular basis, checking to see, hey, is there new Parquet files, new CSV files, new JSON files, and then add those. So that way you don't have to, so won't even check. It'll just actually know because it actually uses S3 events. So the minute that a new file enters that bucket, it'll know to then go ingest that into the table. So it'll actually just ingest it as it goes. So then you basically have this sort of real-time ingestion from file to table. And again, you have file upload. There's a lot of people, I've gone to a lot of companies where they're just uploading random CSV files and random JSON files and random Parquet files and running just basic analytics right off of that. And oftentimes they're just uploading them all over the place. But with a file upload feature, they can upload it into their Dremio environment. They can go run those ad hoc queries and get to work right away. So it's a really quick way to kind of just get working with Iceberg tables in Dremio, because Dremio just takes that uploaded file, turns it into an Iceberg table in your catalog. So just a real convenient way. A lot of companies I know are just working with file uploads to do a lot of their analytics, and this just makes that real easy in the Iceberg Lakehouse world. But again, that's what you can do in Dremio. Now, outside of Dremio, there's a lot of tools just dedicated to moving data from one place to another. Okay, you have sort of open source technologies like Apache Spark, Apache Flink. Spark mostly for like batch type ingestion, Flink for like streaming type ingestion where it's just continuous, but they can connect to Dremio Catalog. Because again, Dremio Catalog supports the Iceberg REST API. It's a standard. And because of that, it can talk to all tools that apply that standard, which include a whole lot more, okay? But again, you can use external engines such as Spark, okay? And again, we mentioned Spark. Spark is very popular for batch ingestion. Fivetran, if you're looking for a commercial option, Fivetran is probably the most popular option for doing batch ingestion, where you go in there, you can check from like hundreds of connectors and say, hey, take the data from any of these connectors, which could be, not just databases and data warehouses, but it could also be your CRM, your Salesforce, things like that, and just load them right up into Iceberg from there. And then again, you just then connect. You either do it directly into Dremio Catalog, because you can connect whatever catalog you have, including your Dremio Catalog, because it supports the REST standard. But you can also connect, if you have another catalog, then you just connect that catalog to Dremio. So again, everything is interoperable. That's the beauty of Iceberg lakehouses. Okay, if you're doing streaming, if you want to use open source tools, there's tools like Apache Flink, Apache Kafka Connect that can land data in there. But also when you're taking a look at commercial options, companies that can help you make streaming a lot easier, and all of them have been introducing features for landing that data into Iceberg. So that way your streams just go right into Iceberg right off the bat. These are companies like Confluent, Red Panda, Ivan, Stream Native, Rising Wave, all have different products to kind of help facilitate you taking your data streams and landing them into Iceberg. But just to kind of remind us about best practices, you want to make sure you use micro batch patterns as much as possible. Like again, at the end of the day, you want to batch as much as possible. The reason is like the smaller your batches, the more often you're writing, the more smaller files you're creating, which means you're going to run into the small file problem. Now, again, Dremio will mitigate a lot of that through our automatic ingestion. But again, you'll need less of it the more smarter your ingestion patterns are. Okay. Do data quality checks as well. Okay. Basically, and the data quality checks don't have to be super sophisticated. In Dremio, you can just create a view that's a data quality check. Just create a view that basically does a check, has all your checks, and then you can quickly click on it and see, hey, are there any records in this view? Like theoretically, if you filtered and only were looking for records that are a problem, that view should have 0 records. So you just query the view, and if you have 0 records, then that data is fine. Okay, so that way you have something you can physically audit. Ideally, you might have that you can leverage those kinds of views and using a framework like Airflow, because then if you're orchestrating your ingestion jobs with something like Airflow or DBT, you can sit there and say, hey, if this table has 0 records, shoot off an alert or something like that, so that way people can go in there and fix things. Okay, lineage. Now, this is why doing ELT with Dremio is really valuable, because if you don't make really any of if you just connect your data to Dremio before moving it, and then handle as much as possible within Dremio, you get full lineage of the data. You can see like where it came from, how it was changed, who changed it. You get all this auditability of how your data is evolving. So trying to keep stuff as much as so while everything is open and everything is interoperable, there is a tremendous value in trying to keep as much of the work done in Dremio to have that observability. Okay. Now, there's another feature called merge. That's a mix of like appending new data and upserting with new data. I would use it sparingly, okay, because doing upserts is just much more expensive. Works if you have to, okay, but appending is going to be much faster because you're not having to touch the old data. You're just adding the new data. Well, merges then have to go take a look at the old data, make sure none of that was changed, and that's just a longer process. Okay, make sure you have very clear naming conventions. Okay, again, comes down to that whole cultural piece, kind of like talking to upstream, downstream, making sure not only that you guys agree on what schemas should be, but also what things should be named, so that way you know if you're dealing with like, is this the production level data that I should be building reports off of, or is this data that is not ready yet? A lot of times you hear bronze, silver, gold, but it doesn't have to be that. People use all sorts of different names, whether it's like raw, staging, production, or so forth. Like, where does this data fall into? Is this the data without any changes? Is this the data in some sort of intermediate state, or is this the data in the final usable state? Okay, you want to have some sort of terminology to kind of be able to distinguish those 3 things in there. Okay. And summary and next steps. So again, what should you be doing? Explore getting into Iceberg. Explore your ingestion options. Try out those Dremio features that I mentioned. Take a look at some of these other platforms that I've mentioned and see if they can do what you need to facilitate your existing sort of workflows. Do leverage Dremio. And by leveraging Dremio's catalog, you are leveraging Apache Polaris. You're leveraging the best in catalog open source. And you're getting that interoperable catalog that's going to be able to govern your data sets, okay, and basically make you more secure, not just because you can define who can access a table, but you won't need to give them storage credentials directly because you have credential vending, okay? Again, always lean towards, basically lean towards writing less often as possible. Now, again, it depends on sort of the needs of the end user. This is why, again, you need to have those conversations with whoever is going to use the data, along with who's providing the data upstream. So that way you can figure out sort of what's going to be the best way for you to group writes and what is the latency needs of the end user. and then again build reliable pipelines. So this is just big and putting in data quality checks, so that way you are alert when bad things happen. Okay, putting in fail safes, so that way if something goes wrong, things like maybe a job retries, it knows how it does. You have like watermarking, so that way you know where to retry from. Things like this. So basically, you want to make sure you plan for all the things that can and sometimes will go wrong. So you want to make sure people can't access the data they can't access, but you want to make sure you're getting them data that they're actually asking for and looking for, and you want to automate about as much of that as possible, so that way you can keep up with it. But with that, I want to if you haven't gotten hands-on with the new Dremio Cloud, I invite you to do so. So scan this QR code. This will take you to a hands-on sort of self-guided workshop where you can just follow the steps on setting up for Dremio Cloud and basically playing with many of the Dremio Cloud features with sample queries, and just have a great experience trying Dremio Cloud, so you can see the power that's at your fingertips when you're taking advantage of Dremio Cloud. The ability to federate queries across different sources, being able to leverage AI to run analytics on your full data real estate, getting the performance and power interoperability of Apache Iceberg, not just by being able to work with data in Apache Iceberg, but having a open catalog that allows you to connect with the entire ecosystem of tools. Basically, everything you need to really accelerate your data platform to the next level. So go scan this QR code, work through this exercise. I'll see you later. Have a great day and enjoy. Now it's time for a demo. I'll see you there. Hey everybody, and welcome to this demonstration of ingestion functionalities in Dremio. So this is not a end-all be-all of the different ways you can create a table in Dremio, but I want to show you some of the more fun ways that might be useful for definitely different types of workflows. Now, of course, it's Dremio's catalog, and again, Dremio's open catalog. When you're on a Dremio Cloud account, you can see right here, this section that says namespaces. This namespaces, that is the Dremio catalog, the Dremio open catalog, powered by Apache Polaris. So it's an Iceberg catalog, a lakehouse catalog where you can organize your data. I got all sorts of stuff going on there now, but you can land data in there, not just from Dremio, but from any tool that can land data as Iceberg. You would just connect to the Dremio catalog using the REST catalog interface, and you'd be good to go. But Dremio has lots of functionality that you can take a leverage for getting data into those Iceberg tables in this catalog. And I'm going to show you a few of those. Now, what I've seen in a lot of companies is sometimes people just like to upload a file. They like to upload a CSV file that they exported from Excel, or they like to upload a JSON file or a Parquet file. And they want to just run ad hoc analytics. And you can do that in Dremio. You can do that as easily as just clicking down here to click on Add Data. And you can go here to drag and drop, and you can choose a data file. So right here, I'll just choose this random CSV file right here. Okay, we'll just call this data. And then I can choose where I want this to show up in my catalog. Okay, right now what I'll do is I'm going to add a new namespace for uploads, just so that way to organize. And I'll say, hey, you know what? I want all my uploaded files in this upload space. That way I know where my file uploads are landing. Okay, so then I'll just select that file upload namespace. I'll hit save. Okay, and now I get to choose sort of what file format. So I can say, hey, what kind of, is it a CSV file, a JSON, or a Parquet? It automatically detects that it's a CSV file. It detects that it has a header column, so it's extracting the column names. And as long as this looks about right, we're good to go. And I can go in and I can create the table. And what it's actually doing is actually just taking that CSV file and automatically taking it and turning it into an Iceberg table in my catalog. So now that data is an Iceberg table, okay, which I can now query. Okay, and I can go over here, run a query on that handful of records. Now, generally, you're probably going to want to do this on larger files, but again, this is for demonstration purposes. Now, what if you have a whole bunch of CSV files sitting on S3? So for example, I have an S3 source connected here. So I'm going to go over here. I have a bucket for my demos. Okay, and then if I go in here, see I have this copy into example folder where I have a bunch of CSVs. Okay, and since we're here, let me also point out that I have this PDF example folder with several PDFs, which we'll be using a little bit later on. Okay, but the cool thing is what I can do is I can use the copy into command, okay, in Dremio, and that's going to allow me to target a specific like folder in with files, or in an individual file. But in this case, I'm going to target a whole folder of CSV files and say, hey, you know what? I want to take those CSV files. I want you to take those records and add them to an existing Iceberg table. So let me copy over this script. Okay, so in this case, what I'm doing is I am going to create a folder for us to land this, where I'm going to make this table. Then I'm going to actually create the table. The reason why it's important to create the table first is because CSV, it's going to assume that all the columns in a CSV file are text. But the beauty of copy into, since the table itself already has a schema, this transactions table has a schema, it can automatically convert the CSV's columns into that schema. Okay, so it'll basically coerce the CSV into that schema, so we don't have to worry about doing sort of data type changes later and all these alter statements. We're just cutting right to the chase, real convenient. So then here I'm just saying, hey, copy into this new table from this particular folder in my S3 source. Basically, get and look for all the files that end in CSV. They should be CSV files, and here's some details about how to interpret those CSV files. Okay, that way if you had like a tab delimited CSV file or some other delimiters, you have that flexibility. And then I can just run this and let's watch it go. Okay, so first it's going to go create the folder. Now it's going to create the table. And now it's going to begin reading those CSV files, turning those into records that it can then basically add to that table. And that's done. So now if I go back over here, back to my catalog, I'm going to head over here to Dremio, go to the copy demo. And there's the transactions table, and I can query the data. Okay, and you can actually set it up. There's another feature called copy pipe, or create pipe. And what it does, it creates sort of a regularly running copy into. So this copy into command, if you have like a folder where Parquet files or CSV files or JSON files are landing on a regular basis, and you want to have a continual sort of job taking those files and adding them to an Iceberg table, there is a feature for that in Dremio called create pipe. That'll do that. But you can see we added those files from the CSV file. Now for the super fancy thing to show you, I want to show you AI generate. So the idea here is, remember those PDF files? Now PDF files aren't structured data, so I can't really run a SQL command across those files. Now what Dremio does allow you to do is allows you to list files in a bucket. So let me actually first show you that. Okay. So in this case, let's see here. So if I were to do select star from and essentially I use the table function, which just says, hey, make a table out of what's inside what I'm passing to the function. This list files function is then going to basically create a list that then turns into a table. So what happens when I run this query, I'm going to get a list of files in that particular folder in my bucket. So there's the 3 PDF files, and it has information out of those files. But again, they're not, but there's data in those files. Okay, there's actually like names of people, their ages, their birthdays. And I want to put that in a table. Okay, what I can do is I can use this pattern right here. Okay, so first we're going to do is, again, create another folder for us to sort of organize everything. Then I'm going to create a table called people. But what I want to do is I want to use this AI generate function. So I'm saying, okay, hey, for my columns, there's going to be 2 columns. The first column, I'm just taking the path from this JSON here. So again, you saw that list files just gave me that 1 column file, which has this sort of this struct right here. And I'm just going to take the path value as one of the columns in my new table. The second column is going to be the result of this AI generate function. So this AI generate function is going to return a struct with a schema that I want for every file that I pass it. So in this case, I'm saying, hey, you know what? I want you to extract these values for every file. Now the schema that I want every row you return me to have is this. Okay, and then the name of this column with this struct is going to be called extracted. Now where are you getting this list of files? Well, from the list file, from that list that we got from list files. And again, I only want to scan the files that have PDF at the end. So now if I run this, what it's going to do now, it's going to, again, create that folder. And now it's going to create a table based on the results of that query. The results of that query are, again, going through each Parquet file, each PDF file, interpreting the PDF file using AI to get structured results. And then here we go. So again, I just took a bunch of PDF files, and now I go over to Dremio AI generate example. Let's query the actual table. There should be 3 records because I was 3 PDF files. Okay, and there we can see the results. Okay, we can see that we got that first name field, we got that age field, and we got that birth date field. Then I can, further flatten it afterwards using Dremio's semantic layer, create like a view that flattens out these fields, and so forth. Okay, or I could do something like this. I could say, hey, you know what? Select extracted name as name. Okay. Oh. There we go. Well, you get the idea. They say I have to typecast it, but how to typecast it is escaping me at the moment. But yes, okay, so there you go. We've extracted this structured data from PDFs. And again, imagine you have a bunch of forms you want to fill out. Instead of having to separately create a separate AI process or a separate pipeline to take all those PDFs and then turn them into data, and then separately ingest that data into an Iceberg table, you can just skip all those steps, go directly to the Iceberg table using functions like AI generate. So what we learned today, we could, for ad hoc workflows for that employee who just kind of likes to upload their quick files to run some SQL files against, you can upload a file. For those buckets where you have loads of CSV, JSON, Parquet files, you got copy into to help you get that data into an Iceberg table. And for unstructured data like PDFs and images, Dremio can leverage functions like AI generate, AI complete, AI classify that help you generate structured data from your unstructured data so you can run analytics on that data. All of this is just with Dremio. And again, the catalog is a Iceberg catalog, so you can use any tool you want to land that data in Iceberg, and then you get all the nice features of Dremio that are helping accelerate your queries and help deliver it for your business line analytics. Thank you very much. I hope you guys enjoyed the demo. I'll see you all later. Have a great one.